Today's lesson will finish up section 7.1. It's called Basic Trig Identities. So in order to get started with this, I just want to remind you about our discussion of where all the trig functions are positive. All right, so this quadrant would be sine and cosecant. Quadrant would be tangent and cotangent, and this quadrant would be cosine and secant. All right, so this is what the problems are going to look like today. There's two things we have to talk about. Express each value as a function of an angle in quadrant 1. So let me show you. What if I asked you, what's the sine of 130 degrees? I want to write it as an angle in quadrant 1. The way we're going to do this, let's draw it out. 130 puts us right here in the second quadrant. And our reference angle for 130 degrees would be 50. Well, is sine positive or negative in quadrant 2? The answer is sine is positive. So if we were to draw this in quadrant 1, it would actually be the same thing. Whatever we get for the sine of 50 here, it's positive, and in quadrant 1 it's also going to be positive. So what we would do is we would just say that the answer is the sine of 50 degrees. Really, the way these problems are going to work is the answer is always going to be the trig function of the reference angle, but then if the angle drawn is negative, you just put a negative in front. If it's positive, you leave it alone. So what about a problem like this? How about the sine of 220 degrees? Well, 220 would be right here. It passes 180 degrees by 40 degrees. Now is sine positive or negative there? Sine would be negative. The only thing positive there is tangent or cotangent. So because sine is negative here, and we have to draw it as an angle in quadrant 1, we would say the answer is the sine of 40, but that's a positive angle. Because this angle is negative, we would have to put a negative in front. So you're going to draw the trig function. If the problem is negative, then you put a negative in front of the angle in quadrant 1. Let's try a couple more. How about the cosine of 750 degrees? Well, 90, 180, 270, 360, 450, 540, 630, 720, 750 would be right here. Now, we pass 720 by 30 degrees. Is cosine positive or negative there? All trig functions are positive, so the answer for this would just be the cosine of 30 degrees. Cosine of 30 degrees is exactly equal to the cosine of 750 degrees. We'll do one more. How about the cotangent of 330 degrees? 330 is right here with a reference angle of 30. Well, is cotangent positive or negative there? Cotangent, remember C is for cosine. So cotangent would be negative there. If we're going to draw the angle in quadrant 1, we would say that the answer is the cotangent of 30 degrees, but because that angle is negative, the cotangent of 330, in quadrant 4, cotangent's negative. So you would put a negative in front here. All right, and the second piece of what I wanted to do today is talk about how to simplify trig functions. So we're going to be using our identities that we talked about in the previous lesson. And what we're going to do is we're just going to really convert to sines or cosines and reduce. Let me show you. Directions are going to be to simplify. And the first problem looks like this. Cosecant of x minus the cosine of x cotangent of x. So let's convert using our reciprocal identities. 1 over the sine of x minus cosine of x times cosine of x over sine of x. All right, so we just converted using the reciprocal identities. Cosine times cosine is cosine squared. Now we have a common denominator, so we could combine those. Generally, what you want to do if you see something squared is you want to try to look for a Pythagorean identity to simplify. So if you remember, sine squared plus cosine squared is 1. So if we want to figure out what 1 minus cosine squared is, that would just be sine squared. And sine squared over sine, it's just like x squared over x. A sine would cancel out with one of these, and the answer would just be sine of x. Now we'll get into some more of these in section 7 too, but today we're just going to introduce some of this stuff. What about if we had something like this? Cosine squared of a over 1 minus the sine of a. Now we have all sines and cosines, so remember what we said, we want to try to use a Pythagorean identity whenever we see something with a squared in it. So the Pythagorean identity we're always going to keep coming back to is sine squared plus cosine squared is 1. So what cosine squared is cosine squared would be 1 minus sine squared of a. So let's make that substitution. And then the top is the difference of perfect squares. And remember the formula for that. If you have a squared minus b squared, formula would be a plus b times a minus b. So we're just going to factor the top to be 1 minus the sine times 1 plus the sine divided by 1 minus the sine of a. And the answer would be 1 plus the sine of a. Couple more. What if I asked you to simplify cotangent of a divided by the tangent of a? Remember what I said, we should always convert to sines and cosines first. And we're dividing by tangent, which was sine over cosine. Well, if we keep change flip, we get cosine squared of a over sine squared of a, which is just cotangent squared of A. That would be the simplest way to write it. Cosine over sine is cotangent. All right, and I think that should be good enough. So try your homework. The homework, what I'm going to ask you to do is practice 7-1. I would like you to please do numbers 2 to 14 even. Thank you very much. Have a nice day.